Alright, now that you've been introduced to the three formulas you're going to need to know, we're going to spend most of today working with the one that's annually. This is the one that is used the most, and so we're going to sort of attack that first. Tomorrow it'll be very similar, just with variations on what we're doing today. So one of the things you might be asked is to write the equation of a relationship of some amount over time. So when asked to do that, so for example here, it tells you the initial amount is 5,000. Remember that your initial amount is P, so that means P is 5,000. And you have 5% growth. Now remember, growth as R has to be a decimal. So growth does mean it's positive, but divide that 5% by 100, and you'll get that rate as 0.05. So when you plug that in, that means you have A is equal to 5,000 times 1 plus R, so 1 plus 0.05 to the T power. And that is it. If you're asked to write the equation, then you're going to have the amount is equal to something, and it's like the relationship over time. Alright, a decay example is just slightly trickier because you still have to worry about that negative rate. So your initial amount is 300, so that means P is 300. If your decay is 36%, that means your rate is negative, and 36% divided by 100 is 0.36. Alright, so plugging that in, that means A is equal to 300 times 1 plus R. So 1 plus a negative is the same thing as minus to the T power, and you do need to go ahead and simplify that. So A is equal to 300 times 0.64 to the T. And that is that. So writing equations aren't too difficult, and sometimes once you get here, you'll be asked many more questions, but this is just sort of like the first step. You have the equation, and you might have to do more with it later. Alright, now you have 4 different variables in the equation for growth. And at any point in time, you might have to solve for any one of those 4. So I'm going to start bringing you through how to find each one. If you're evaluating A, that's like the easiest one because everything else is on the right, so you won't have to solve for anything. You can just plug in all the numbers, dump it in your calculator, and you're done. So in example 3, Rebecca is thinking about buying a piano for $20,000. So $20,000 will be your P. It is expected to depreciate. Depreciate means decay, so that means we're going to have a negative rate, and it's 1%. So you divide 1% by 100, and you're going to end up with 0.01. And then what will be the value of the piano in 20 years? That was the word years before my thumb got it. Okay, in 20 years, so that means T is 20. Alright, so that means the amount, A, is equal to 20,000 times 1 plus the negative, so minus 0.01 to the 20th power. And when you plug that in your calculator, you should get that it is got an amount of $16,358.14. And guys, use your brains, okay? If it's starting off at 20,000 and it's supposed to get smaller, then this number should be smaller than that one. I do have students who'll try to tell me that it's 25,000 or something, and if it's going down in value, this number has to be less than that number. Okay, example 4. Miss Cudd is thinking about purchasing land in Brazil. These are dreams of mine, not reality. Assuming it will appreciate, so it's going to be getting bigger. Appreciate means positive at the rate of 4%, and divide 4% by 100, and you get that the rate is 0.04. If she purchases the land for $85,000, so that means P is $85,000, what will it be worth in 15 years? So time is 15. So you're plugging those 4 numbers in, so A is equal to P, which was 85,000, times 1 plus r. 1 plus 0.04 is 1.04 to the t power. T is 15. So put that in your calculator and you'll get that it'll be worth $153,080 and about 20 cents. I have 198, so you could leave that as 19 or as 20. Okay, so that's just writing equations and finding A. Of course, you have to do more than that. So, evaluating P. Well, P in the equation is right here. So what that means is once we figure out all our numbers, we'll put our numbers in here, here, and then we'll have to divide both sides by this mess to isolate P. In fact, some students like to do that first. Some students like to, in the very beginning, treat it as a literal equation and divide both sides by 1 plus r to the t. And now you know that P is simply A divided by 1 plus r to the t. And if you're one of my people who wants to do that, you are more than welcome to. In fact, I encourage that line of thinking. But a lot of students like just to have one formula to have memorized, and that is the one formula for annual compounding. Okay, so if Mr. Simpson's house is worth $500,000 after 10 years, we know T is 10. I do want to think about, okay, so assuming a rate of appreciation, so positive of 10%, 10% divided by 100 is 0.1. What did he originally pay for it? So what he originally paid for it happened before this. This is the after amount. So that means A is 500,000, and we're trying to find P. So we have 500,000 is equal to P times 1 plus R. 1 plus 0.1 is 1.1 to the t power. Okay, so if we're trying to solve for P, we're going to divide both sides by this 1.1 to the 10th. And that is a little weird, but totally allowed. As our variables here, we're trying to solve for it, so we want to use inverses. That's being multiplied, so we would divide. So P is equal to that exactly, but since this is a word problem, we are going to want an approximation. And that means it's approximately 71.64 Okay. Yep, that's, hope I'm reading my handwriting there. I think that's the one. Okay. So that's finding P, so you just plug in the other stuff and divide to get P by itself. Finding R. Now R is a little more complicated. Usually as a student this is more frustrating for you because R is in the parentheses and those parentheses are being raised to the t power. So what that means is you're going to end up having to take the t root of both sides in order to get R by itself. So this is like probably the weirdest one, even weirder than the time ones, which are coming after. Okay, so looking at example 6, the Smiths bought a new home 10 years ago, so T is 10, for $120,000. The house is now worth $191. So that means this is P, and now it's $191. Assuming a steady rate of growth, what was the rate of appreciation? And that is a good question. So we're trying to find R. So plugging in our numbers, that means we have 191,000 is equal to 120,000 times 1 plus R to the 10th power. Now in solving for R, we first are going to need to get this by itself, so we need to divide this number away. So divide both sides by 120,000. That cancels out, a lot of those zeros cancel out, and we have 191 over 120 is equal to 1 plus R to the 10th power. Now, to solve for R, we have to get rid of that 10th power. What's the inverse of power? You guys know it's root. So you could say that's the 10th root. And another way of doing that is doing the 1/10 power. So those cancel out, and we have the 10th root of 191 over 120 is equal to 1 plus r. So to solve for r completely, you still need to subtract 1. And so r is equal to the 10th root of 191 over 120 minus 1. And if you put that in your calculator and approximate it, let's do an approximate, r is approximately equal to 0.04757. Now that's the decimal form. So if we wanted that as a percent, we would multiply that by 100, and so that's 4.75 or 76% growth. And that's how we get r.